All right, let's take a little look at final exam review, the packet I gave you for Chapter 8. I'm just going to work through just the odds on this, go down, just give you an idea of how to do some of these problems. Maybe I pick an even or two out of here and there. Let's take a look at the first ones here where we have to graph. Excuse me. So one of the ways to do this is, the best way to do this is to find what your asymptotes are. This guy right here is going to tell you what your vertical asymptote is. It's of the format. This is the way we're looking at it. It's y equals a over x minus h plus k. This is going to tell you what your vertical asymptote is, so that's going to be at x equals 1 on this one. You always take the opposite. Really, it's what makes the bottom equals 0. That's going to be a vertical asymptote. So that's our vertical asymptote there. And our horizontal asymptote is just going to be y equals whatever k is, which in this case is also a positive 1. So that's where you put your asymptotes in. At x equals 1, that's right here. That's a vertical one. And y equals 1 is right here. Now the general shape of these, if a on top is positive, which it is here, it's going to be up here and down here, upper right corner, lower left corner. So if this is multiple choice, it's really all you got to look for. If I'm asking you to graph these out, then you can plug in a couple points just to be sure. So maybe we'll take, I'm going to take a couple points to the right of this asymptote here. So like 2, a 3, and a 4. If you plug in a 2 to the original, let me get rid of that stuff. If you plug in a 2 there, it's going to be 2 minus 1 on the bottom. So 3 over 1 plus 1 at the end is 4. So 2 comma 4 is right here. If we plugged in a 3 instead, it'd be 3 over 2, which is 1.5, plus 1 is 2.5. So this would be at about right here, 2.5. And if you plugged in 4 to this, you would have 4 minus 1 on the bottom. So it'd be 3 on the bottom. 3 over 3 is 1 plus 1. That's 2. So that would be right here. So you can kind of get the general shape then, what this is going to look like. And it will only approach those asymptotes as it goes further out. And on the bottom here, you can kind of just mirror image those points here. Right here, what was the next one down? It was right about here and here. And then just draw your shape in there. And that's pretty much it. So I'm not going to do the whole graph on this one right here, but you can see this one, think of it as a plus 0 underneath and a plus 0 out here for our h and k. In other words, this guy is going to be centered right on the origin in terms of its asymptotes right here and here. So you'll have a shape at the end when you graph it. Looks like this and like this because the 4 on top, that's positive. In general, the bigger that number is, it kind of moves it further away from the origin. That's kind of the idea behind that. But that one would have been pretty easy to graph out. Let's get into some of these simplifying problems. So this is all about canceling out and reducing. It's really two separate problems. The way you want to visualize this is you got a problem where you're reducing 30 over 100, and another problem where you're taking the b cubed over the b to the fourth and simplifying those separately. So 31/100, that's easy. They're both divisible by 10, so that's just 3/10. And the b cubed over b to the fourth, if it helps you to think about this, as a b times b times b. And this is a b times b times b times b, 4 b's underneath, 3 b's on top. You can see 3 cancel out, 1 left on the bottom there. So that's one way to do it, or you can just say, well, 3 on top, 4 on the bottom, going to have 1 left on the bottom after everything cancels. That's fine to think of it that way too. But really, you're doing two different problems. You got the problems, or you got the number aspect of the problems, and you have the variable aspect. All right, let's take a look at 17 down here. So if you have something like this, you have to factor it out, right? This is just your traditional factoring on the top here of splitting this into 2 sets of parentheses. Can't do anything with the a plus 9. You can't do anything at the beginning here like saying, oh, these a's can cancel out, and this can turn into what it'll be a 6 over 1. No, you can't do anything like that, okay? You can only cancel factors. That's really important. But this, sometimes what's on the bottom here does give you a hint as to what this could factor out to on the top. Because if something's going to cancel out, probably be something that's the same there between those. So maybe I'm going to guess an a plus 9. And 9 is a factor of 54. If this would have to be a minus 6 if this was going to make negative 54 when you multiply these two together. So do you end up getting a positive 3a when you do 9a and minus 6a. You put those inners and outers together. Yep, it does work. So it turns out our little guess was correct. So we can just say these cancel out. We're just left with a minus 6. So you've got to factor first. And factor a monomial off if possible. That happens, for example, in this problem over here, where on the bottom, you can see that 6r is a factor of both of those. And when you factor that off, you get 6r times r plus 2. So make sure you get the monomial first if possible. Let's take a look at this one, number 9. It's another one where you just got to do some factoring up front. So let's factor the top first because it looks like the easiest one. Because I know factors of 3 here, well, it's all plus, right? This has to be r plus and r plus because everything's plus signs. Only factors of 3 are 3 and 1. So by golly, that works. It makes 4r in the middle. And on the bottom, if we got an r plus and an r plus, because again, all this is plus here, so it's got to be plus signs, and got to be an r and an r. So factors of 30 that add up to 13 in the middle. Well, I'm guessing one of them's got to be a 3 or a 1 here. So let's say this is a 3, and this would have to be a 10 to make 30, and sure enough, that makes 13r. So those are the ones that cancel out here. You can see the r plus 3's go bye-bye, and we're just left with r plus 1 over r plus 10. And you can't do anything with that. You got to leave it like that. Don't cancel the r's out or anything like that. All right, here's a good example, number 11, of factoring off a monomial first on both of these. Because note on the bottom, everything's divisible by 10. On the top, everything looks like is divisible by 2. So let's do that first. Factoring off the 2 from the top to get 3m squared minus 14m plus 16 at the end there. And on the bottom, factoring off that 10, and I get m squared minus 3m plus 2. So the bottom's definitely the easier one to factor. I could do one other thing here while I'm at it. Let's cancel this and make this a 1/5 instead of 2/10. So I'll fix that there. So now this on the bottom here is going to be 5 times, and let's see if we can factor this out here. I changed colors, but that's all right. And on the top, not quite sure yet, but I'll just set up the parentheses for it. But on the bottom, this is pretty easy, because what are factors of 2? I got to make a negative in the middle, so it's going to have to be m minus and m minus to make a plus 2 at the end, but a negative in the middle. Only possibilities I have are 2 and 1, though. And sure enough, that does make a negative 3m in the middle. But that gives me a good hint for what to try on this up here. I'm guessing there's probably going to be either an m minus 2 and an m minus 1 up there. Let's try out m minus 2 first. So if that's an m there, this has to be a 3m here. And this would have to be a minus 8 in order to make a plus 16. So let's just test it out, see if it works. All right, if I FOILed that out, I'd get my 3m squared and my 16 at the end. I really just got to check to make sure I get a negative 14m in the middle. And I have a negative 6m there and a negative 8m there. It does make a negative 14m. So take advantage of those factors being shown to you. You can use them as good guesses. So these m minus 2's cancel out, and all we're left with is a 3m minus 8 over 5 times m minus 1. And that's it. That was a little bit more difficult factoring. I might not even give you one that tough in terms of the Algebra 2 exam, but it's good practice for some of that types of factoring you have to do sometimes. All right, multiplication ones, don't change anything. Everything is pretty much the same as what we were just doing with simplifying just regular non-multiplication problems. Just cancel things out. So whatever is on the bottom and the top that you can cancel out between the two, just take care of it. So for example, in this one here, I see I've got a 10 and a 10. Let's just cancel them right out. Let's get rid of them. And I've got an 8 and a 6 that should reduce to a 4 and a 3, both divisible by 3. All right, and if you want to do this now and like do a separate step where you rewrite everything because you don't want to get too much action going on there, that's fine. I'm going to rewrite this in another step. This is going to be 3v on the bottom here. And now I'm going to notice that, well, on the bottom here, I can think about this as a v to the first. So this v and this v, if we put those together, it makes v cubed, which is the same as what I have up here. So I could just go and cancel out this, and this, and they're all going to go bye-bye. All right, v cubed over v cubed cancels out. So I'm only left with a 4v on top and a 3 on the bottom. And if you lose track of things that you want to use in your final answer, I like to go in and like circle the things that are still left over. And that way I don't forget to write them in my final answer. All right, let's go on to this next one here. We got division. All we have to do, though, remember, you take your second fraction and you take the reciprocal of that, or flip it, and then multiply. Okay, so 8p over 3 times 2p squared over 8p. Now, if you want, you could have, at the beginning, reduced this a little bit. 8 over 2 is 4. This p over p squared. You could do that, but sometimes it's just good to stick with one method and then start canceling next. Because you notice what happens here. I've got an 8p and an 8p. Those cancel completely out. And that's pretty much all you have to do on this one, because all that's left are things that aren't cancelable anymore. I have everything I need here, just the 2p squared on top and the 3 on the bottom. And that's it. That's all you can do. All right, here's one that's already factored for you. So these are, in my opinion, the easiest ones. Everything's already done. You just got to cancel like factors, only like factors. So what are my like factors? I got v plus 3s, v minus 3s, 7s. The answer is simply v minus 9. Can't get much easier than that. Here's one that is a division problem, but again, we just got to remember, flip it, right? I'm going to rewrite this as n plus 7 times n plus 3 over n plus 3. If you had wanted to, at the beginning, cancel those out, you could have done that, but we'll do it in the next step. Now I got to take the reciprocal of it, so it's n plus 2 over n plus 7. Now remember, n plus 7 squared is the same as n plus 7 times n plus 7. I'm going to write it out that way just so I don't forget. So then I can have a cancel fest here. N plus 3s are gone. One of the n plus 7s is gone. I'm left with an n plus 2 and an n plus 7. That's it. That's all we can do. N plus 2 over n plus 7. Those cannot be simplified. That's your final answer. So now we got to do a little factoring on some of these ones. But this is a good example of factoring a monomial off. All right, so this first one you see, the top is, this needs to be factored. This can be factored with a monomial. This is as factored as it can get, so I don't have to worry about that. So it's really just the first fraction. So that on top is going to be some r and r, and on the bottom, well, I can factor 7r off of this. That's my common factor, so this is going to be r plus 1. So I'm betting there is going to be an r plus 1, or maybe an r plus 8 as a factor of this. It can't be r plus 8 because 8's not a factor of 10. So it's got to be an r plus 1 up here. And if that's going to be a plus 1, this has to be plus 10 to make 1 times 10 to equal the 10. And the 1r and the 10r makes 11r, so it checks out. So we have everything we need there. On that one, just rewrite the second half, 7r, r plus 8. Now we can go and look, see what we can cancel. R plus 1s. All of 7r cancels out. So we're just left with r plus 10 over r plus 8. Okay, and that's it. That's your answer there. Here's another one we got to factor, but we're going to have division this time. But again, so remember, these guys, these guys right here are going to be hints for us. K plus 6, k minus 7, probably going to be hints as to what these might factor into, okay? So let's go ahead and do that. I'm going to take this and say this is k plus 6 over k minus 7 times, I'm going to rewrite this as k squared minus 6k minus 7, just flipping this fraction right here. All right, and then the bottom now is k squared plus 8k plus 7. So now I got to factor that out, the second fraction here. So on the top here, looks like I'm going to have what? I got to have factors of minus 7 that subtract to make a negative 6k. So that means it has to be plus minus. So maybe k minus 7, k plus 1. That does in fact work, right? We get a negative 6k in the middle, and we get a minus 7 at the end. And on this one here, looks like I'm going to have factors of 7 they have to add to make 8. So that's 7 and 1 also. But in this case, everything's got to be plus. So it's k plus 1, k plus 7. So now I can go into my factoring mode, or sorry, canceling mode. K minus 7s cancel, k plus 1's cancel. I've got a k plus 6 and a k plus 7 left. So final answer is k plus 6 over k plus 7. All right, moving on here. This one's a little bit more difficult. And I'll go into parts of this one just because it's a good one to look at where you don't have to do nearly as much work. Because look at the very beginning, we have two factors exactly the same. Let's just go ahead and cancel those out. Get rid of them. This turns into a new problem. Now it's just 9x squared plus 27x over x squared plus 12x plus 27. And now it's just a matter of looking at this one and saying, well, on the top I can factor out a 9x from that. So it's just going to be x plus 3 left over. And if you're never quite positive about if you did that factoring of a monomial correctly, multiply it back out. Do you end up with what you started off with up here? If you do, you did it right. Okay. So this here on the bottom is factorable. So you can kind of guess what one of the factors might be, right? One of them is going to be probably an x plus 3, because that's one of our factors on the bottom here. So if that's 3, then this would have to be an x plus 9, because we need factors that will multiply to make 27. 3 times 9. Do those sum up in the middle to make 12x? They sure do. So that is the way we'd want to factor it. And you can see that the x plus 3's cancel out. So our final answer, we're just left with 9x over x plus 9. All done. Can't do anything with this 9 and this 9. All right, only can cancel factors. All right, getting close to the end here. This one's a little bit more complicated. I'm not going to do this particular one here. Probably won't have one this busy on yours just for sake of time here. But let's look at the adding ones. All right, sometimes on the adding ones, you're going to be given a denominator that's also, or it's already a common denominator. So all you have to do when it's adding or subtracting is just add or subtract the tops. All right, so this just turns into really this r plus 2 plus r minus 3 all over the same denominator, 6r plus 4. So it's really just a simple r plus r is 2r, and then 2 minus 3 is minus 1. That's all you have to do. If you could do a little bit of canceling after that, that's fine, but don't be tempted to take this 2 and the 6 and cancel those out. The 2 is part of this whole 2r minus 1, so just got to leave it. All right, let's take one that's a little bit tougher, one that does not have a common denominator. So the two denominators now are 2xy squared and 5xy. Let's start with the numbers. If I'm looking for a common denominator between 2 and 5, it would be 10, right? Or at least common multiple, right? So that'd be 10, smallest number both of them divide into. They both have an x, so I'm going to say one x. This one has a y squared and this one has a y. I got to use the biggest one basically, which is y squared. That's the smallest value that both y squared and y divide into evenly. So I need to change each one of these to a 10x y squared. So remember, basically you're just going to multiply the top and the bottom by whatever's missing. So let me move this over a little bit here. So when you do that, on this one here, on the top and the bottom of the 2x, I'll write this out. We've got 2x over 2xy squared. And you can multiply the top and the bottom of this by, well, it needs 5. And that's all it really needs. It has the xy squared in it already. So I just need to multiply the top and the bottom by 5. And then on the 3y over 5xy, well, that needs a y squared, and that needs this to be 10. So it needs to be multiplied by 2 and y on the top and bottom. Getting a little tight there. So this now becomes 10x, just multiplying these two guys together here. 10x on the top for that one. This one over here becomes 6y squared plus 6y squared. All over, well, now they have the common denominator 10xy squared that I can put together. And this is a little bit reducible here. There's something I actually could have done in the beginning to fix this, but you can see the top, I could factor a 2 out of that, and I could factor 2 out the bottom. So if I just do it this way, divide both the bottom and the top by 2, I could rewrite this as 5x plus 3y squared over 5x y squared. But that's all I could do. The reason I said you could have done that at the beginning, notice I could have canceled those 2's out right at the beginning. Similarly, we could have actually taken these x's and canceled them, and these y's and canceled them, and ended up with basically 1y squared plus 3 over 5x. If you would have started with that, you would have gotten the same result. The common denominator would have still been xy squared, but it would have been a 5xy squared. So it just depends if you catch that at the beginning where you can cancel those out first. Sometimes you want to do that. Sometimes it actually doesn't make the problem a whole lot harder or easier when it comes down to it in the long run. All right, let's take a look at this one. In terms of common denominators, I'm going to make this a little bit smaller too, if I can. In terms of common denominators, think about this as a 2b plus 3, and this is just 5b. They're completely different except for having a b in them, but they don't have any common factors. So the common denominator is just going to be 5b times 2b plus 3. That's as good as you can get with this one. So if I'm going to change these, that means this 6b on the top of this one needs to be multiplied by a 2b plus 3, because I'll need to multiply the bottom also by 2b plus 3 to match that up. And then this 5b over here is going to need to be multiplied by a 5b, because I need it to match up. This thing's missing a 5b. I need to multiply by 5b on the top and the bottom and still have 2b plus 3. So now I can write that as one fraction with 5b times 2b plus 3 is the denominator. I can multiply out the top here. That would make 12b squared plus 18b, and multiply out the top here. That's plus 25b squared. So that makes 37b squared plus 18b over 5b, and then 2b plus 3. And similarly on this one, we see there's actually a b in common between the tops and the bottoms. I could basically divide everything by b. Would cancel this out and this one out, and this would just be a single b, which would have been 37b plus 18 over 5 times 2b plus 3 as a final answer. I could have done one little step again at the beginning to make this problem, in this case it would have made it a little bit easier. I could have canceled those b's out at the very beginning and just said, oh, we have 6 over 5b. And that would have got rid of that b that we just did here at the very beginning, but it still works out the same way, that particular problem. All right, on to, let's do one of these that has subtraction, and then we'll do some of the problems that have equations for these. This one, here's my common denominator. Basically, I just got to put those two together, x minus 3 times x plus 1. So this one's going to be missing an x minus 1. This one is missing the x minus 3 on the top and the bottom. So I'm just multiplying the bottom of this one by x plus 1, the bottom of this one by x minus 3 also to balance it out. So when you do that, the top of this becomes 3x squared minus 3x. The top of this one becomes, I'm going to write this out like this first before multiplying it out, because there is a reason for that. And this is x minus 3, x plus 1. That's just our new common denominator here. The reason I'm waiting on this one is when you multiply this out, you've got to distribute that minus sign. Okay, so that minus sign that we saw right at the beginning here, we're subtracting these two, has to be distributed. That's super duper important. So this becomes 3x squared minus 3x minus 3x squared. Now I'm going to distribute this, and then the negative 3x times the negative 3 over here ends up being plus 9x all over x minus 3, x plus 1. So we can do a little simplifying here. Notice that we have a 3x squared minus 3x squared. Those are gone. So now all I have to do is combine these x's up here, which makes 6x over x minus 3, x plus 1. And that is as far as you can take it. All right, next couple of problems, very similar to that. So I'm going to skip down here to these equations. So the equations, there's a super duper important step we have to do. And first thing we do is find a common denominator. Okay, what's the common denominator between 2n, n, and n? That's just going to be 2n. That's the smallest number or smallest expression that n, and 2n divide into. But here's the key. We're now going to take that common denominator and we're going to multiply every single term by it. So now I'm going to take this 1 over 2n. multiply it by 2n. All right, and then minus the n plus 4 over n. I'm going to multiply that by the 2n. And then on the right-hand side, I've got 2 over n. I'm going to multiply that by the 2n as well. So I take every single term and multiply it by that. Because what happens when I do that is we get things to cancel out. Those cancel out. All I'm left with is 1. And then this n canceled with this. So all I'm left with is going to be, I'm going to write the 2 out front here, 2 times n plus 4. All right, 2 times the whole n plus 4. And on the right-hand side here, the n's cancel out. I'm just left with 2 times 2. Well, that turns this into a lot easier problem now. 1 minus 2n minus 8 equals 4. That's a pretty simple equation to solve. All right, if you move things around a little bit, let's see, this would be negative 2n minus 7 equals 4. Add a 7 to both sides equals 11. Divide both sides by negative 2. You get n equals negative 11 halves. All right, so super duper important at the beginning. Find the common denominator, multiply every single term by all 3 terms. Okay, really what we're doing is we're multiplying both sides by the same number so it stays balanced. Property of equality that way. All right, let's try another one here. All right, so this one you got 1/6 plus 6 over x equals 1/2. What's the common denominator? Well, in this case, what's the number that both 2 and 6 divide into? The smallest number? Well, that would be 6. But then we got this x that would also have to be part of it too. Okay, so yeah, because neither one of these guys had the x, and this one doesn't have the 6. So, but instead of trying to make these all have the same common denominator, add them all up and stuff like that, again, our thing is to multiply each term by the common denominator here, okay? So we're going to take 1 over 6, and we're going to multiply that times 6x. We're going to take plus 6 over x. We're going to multiply that by 6x. And on the right-hand side, we've got 1/2. You write it in red like the other ones. We have 1/2 times 6x. Multiplied every single term by 6x. Things cancel out. We get rid of our fractions. 6's cancel here. We're just left with an x and a 1. So that's just x. This x and this x cancel here. We're just left with 6 times 6. So that's 36. This 2 cancels with this 6. So that's 3. So I'm left with this 3x. That's pretty easy to solve. Bring the x to the other side. Subtract an x. Subtract an x. 36 equals 2x. So x is equal to 18 when you divide by 2. And we'll do one a little bit more difficult one here. I'm going to do that one as well. Let's take a look at 43, because this one's going to require some factoring. Now, there's something you could do first, just to make this problem a little bit easier, which is combine these two fractions. They both have the same denominator. So let's put them together, okay? If I subtracted these two, it's just going to turn into 8 over v minus 3 equals, so it's v minus 7 minus 1. That's just going to be v minus 8 over v squared plus 3v minus 18. All right, now I need to factor this guy here. All right, I'm guessing one of my factors, though, is going to be v minus 3. So it'll be an educated guess for us. We'll have v minus 8 on top. On the bottom, let's say we have one of them a v minus 3. If one of them is minus 3, the other one, to make 18, would have to be a v plus 6. And sure enough, negative 3v plus 6v, subtract to make positive 3v. So our guess was good. So now we need to do the common denominator thing again. Notice we've got v minus 3 and a v minus 3 here. So that's got to be one of our factors of our denominator. But then we have the v plus 6 that this one has, and this one does not. So now we are ready to multiply through by this common denominator, okay? So I'm just going to keep it in the same line here. I'm going to multiply this side by v minus 3, v plus 6, and this side by v minus 3, v plus 6. So the right-hand side, that works out nicely because everything cancels out. We're just left with v minus 8. Well, that works out nice. On the right-hand side, or left-hand side, though, we have the v minus 3's canceling out, but I'm left with a v plus 6 and an 8. So I still have a v plus 6 times 8 on this side. But that ends up being pretty easy. Just distribute 8v plus 48 equals v minus 8. Bring all my v's to the left. That makes 7v. all my numbers to the right. That's going to make a negative 56. Divide both sides by 7, and we end up with v equals negative 8. Now some of these, though, you got to double check to make sure that there's not any extraneous roots. All right, I haven't done that yet here. But make sure if you plug in our negative 8 into the original function, you don't want to get division by 0. If you do, then it's not going to be a solution for us. And in this case, it works out okay. So it is a real solution. Other than that, this next problem, pretty similar. This is our last one, I believe. I'll just take us through the first part of this one, which is to find the common denominator. Now you might notice again on this one, you already have two things that have the same denominator here, 7 over n and 1 over n. So if you wanted to subtract 1 over n from both sides, you could turn this into 6 over n on the left if you brought this to this side by subtracting it. 7 over n minus 1 over n makes 6 over n. Then you're just left with this on this side, but you got to factor that. It's going to be n times n minus 3. So now you're ready to find a common denominator. Both of them have n. Only thing that's missing from this one is an n minus 3. So your common denominator here then is going to be n times n minus 3. Let's do this in our head. If I multiply the right-hand side by n times n minus 3, that cancels out completely, right? I'm just left with a 1. If I take this and multiply the right-hand side, well, the n's are going to cancel out, right? So it's just going to be the 6 times the n minus 3. So now we're ready to just distribute. Bring this to the other side. So 6n equals 19, n equals 19/6. So don't be afraid if you end up with a weird fraction sometimes on these. That's perfectly normal. So that's some of your solutions there, at least the odds on this problem packet for the final exam, Chapter 8 stuff. That covers everything. Some of those problems are a little bit more difficult than what I'm going to give you, but they're a good challenge for you. If you can get the tough ones that involve a lot more factoring maybe, then that means you're going to do really well on some of the easier ones.